Hello, this is the lecture series Picture This, where we are looking at pictograms. This is part 2, the history of pictograms. Let's get started. So just to recap from what we talked about in part 1, pictograms, or pictographs as they're sometimes called, are a type of sign, and they are a representational type of sign. They are also characterized by having elemental forms. So these graphic, representational, elemental, and immediately recognizable by all pictograms could or often depict universal, immediately recognizable objects, places, human gestures, and actions. And another key component of pictograms are they are very easily deciphered by everybody and across all language barriers. That's really where the idea of universal depiction comes in. So anybody around the world should be able to look at these visuals and understand what they're communicating. And we often come into contact with pictograms every day, and they are some of the very first signs that we learn as children. And because of this, you've probably never stopped to consider who made these images and why. So we will look at those today. So it all starts with ISOTYPE. ISOTYPE is an acronym standing for the International System of Typographic Picture Education. And this organization was developed in the 1920s by a man from Austria who was a social scientist and philosopher. His name was Otto Neurath. And he developed this system called ISOTYPE as a method for visual statistics. So as a child, Neurath was fascinated by the function of Egyptian hieroglyphics and how through their forms they were able to communicate a story. So in 1925, Neurath became the head of the Social and Economic Museum of Vienna, Austria, and this venue allowed him the opportunity to showcase his intellectual and educational ideals using this symbol-based language as an alternative to written language that he had been studying and thinking about. So that is where ISOTYPE originally came from. These are some examples of Neurath's ISOTYPE pictograms. So one essential member of Neurath's team was his graphic designer. His name was Gerd Arndts, and he was tasked with making ISOTYPE's pictograms and visual signs. Arndts was really influenced by the expressionist and constructivist movements of the time. And in the end, Arndts designed around 4,000 signs, which all revolved around symbolizing key data from industry, demographics, politics, and economy, since they were used in this museum. So here's an example from a book. You can see, again, this was like the 1920s, 1930s, so automobiles were new, right, on the roads. So again, Neurath and Arndts had to think about how do you visually depict how people should drive on a road, right? Road signs. These were all new things that had to be thought of and developed at that time period. So visual education was always the prime motive behind ISOTYPE. It wasn't intended to replace like a verbal language, but it was considered, in quotes, helping language to be accompanied by verbal elements. And Neurath was convinced that his, in quotes, word language without words would enhance education and help facilitate international understanding of concepts. And we absolutely use pictograms and visual depictions in education today. So he was right. So here is the pictogram developed to represent family. Here's another example of one of the ISOTYPE pictograms. So being the administrator of the museum, which had a lot of demographics and statistical data that it was representing, Neurath really rejected using histograms and other like pie charts, bar graphs, other numerical data sets. And he felt like displaying these facts with a more easily understood visual form was easier for the viewers of the information. So he liked representing quantities by just showing more of the same symbol. So for example, there's the sign for man, and then you have a whole bunch of men together to mean group. So if you wanted to distinguish data sets where there was 50 people here and 100 people there, Neurath thought it was easier to just show, 5 people representing 50 and 10 people representing 100 as a number of little pictograms set together versus having the numbers represented there. He felt like the visual was more impactful and was an easier for the viewer to comprehend. Neurath and Arndt's imagery definitely reflected like the cultural blind spots of their era. So today, a lot of their symbols would definitely be questioned for stereotyping and using a lot of assumptions about women and family and different races and cultures of people, like in this last example. But at the same time, there wasn't that awareness back then, and these images helped viewers understand who different groups of people were. So here's a spread showing how we're using the ISOTYPE pictograms to display data, like I was kind of talking about earlier. So to quote Neurath, he says, especially important part in the ISOTYPE system, as it is presently used, is taken by the pictures giving statistics or the relation between amounts of different things. Amount pictures or number fact pictures, to most men, the reading of long lines of numbers is a great trouble. They put down a book when they see it has in it numbers or curves. But pictures are an attraction. This fact gives the ISOTYPE system a special value for all sorts of education. And again, I think everyone can clearly see that. We definitely use this concept still today when creating visual graphics to represent data and statistics, right? People love pictures, people hate reading. So you can very quickly look at this poster or whatever it was and see that there were a lot more cars in North and South America in 1929 than in Europe, right? If nothing else, you instantly understand that's what this poster is communicating. Here is another poster from the museum, again using the visuals to represent data. Neurath felt like it wasn't necessary for the readers of ISOTYPE pictures to have the complete knowledge of all the rules around the ISOTYPE system, because without even being conscious of the reason why the viewer understands the pictures, the viewer understands the pictures. So he felt like to be successful, anybody should be able to look at these visuals with no extra knowledge to understand the, quote, words of the picture language. And I think he was very successful with that, right? You can definitely understand what we're talking about in this poster, even if you don't understand words like rationalization. You kind of get that between 1923 and 1928, there are a lot less people working, but there's more coal being produced. Okay, so after Neurath and ISOTYPE, there are a couple other designers who really influenced pictograms in graphic communication. So we're going to go over a couple more people. The first one being Henry Dreyfuss. So if ISOTYPE was developed in the 1920s and 30s, Henry Dreyfuss started his work in the 1950s through the early 1970s. So this was, figure 15, 20 years after the introduction of ISOTYPE and the idea of pictograms to communicate data was out there. So Henry Dreyfuss spent most of his career as an industrial designer, and he focused on creating machinery, and he became interested in the study of symbols because he felt like there had to be a more efficient way to design control panels for equipment, because traditionally they would write on the control panels things like on, off, up, down, stop, start. And Dreyfuss just felt like there had to be a better way using symbols to communicate to people how to effectively operate and safely operate the machinery. So he ended up replacing these words like on, off, stop, up, down, etc. to standardize in an international labeling pictograms, and this was adopted as a standard across all machinery around the globe, and it actually definitely enhanced safety and clarity. So if you ever questioned why any of your power buttons look the way they look with the little symbols, you can thank Henry Dreyfuss for that. So you can see in the photographs, you might have never thought about it before, but maybe you did. It's like a picture of like my power strip and that little toggle between on and off. So the straight bar symbolizes or is the sign for on, and the circle would be off. And then if you've ever thought about like the power button on your computer, the second picture, that is supposedly like the on and the off imagery together to create that new visual, which means the one button turns things both on and off. So that's kind of cool, right? And then the last picture on the far right is showing the symbols he developed for up, down, and stop. aka off. All right, so that's kind of cool, I think. Again, things you see and use every day and probably never really thought about. But a designer had to develop that language. All right, so once Henry Dreyfuss developed these first set of safety standardization symbols, his interest really grew. So he got his wife, Doris, and another designer named Paul Clifton together, and they ended up assembling, collating, and standardizing a huge database of 20,000 symbols from around the world. This was in the 1960s. 20,000 symbols from around the world. It's crazy. There was not email back then to like have email people symbols. Okay, so by 1972, Dreyfuss and his staff had codified and published these symbols in an attempt to create the first unified symbol reference. And the document was called the Symbol Source Book. You can still buy it on Amazon today. So that's a picture of the cover and the inside cover. And here's a couple pages of the book. So again, it's crazy. It's all different signs and symbols that are used around the world. And they're kind of classified into different categories. So he kind of tried to categorize them by type of symbol, discipline, color, graphic form, and even to make this source book truly universal, the table of contents was written in 17 other languages in addition to English. So that's quite a crazy feat by Henry Dreyfuss. And near the end of his career in the early 70s, Henry Dreyfuss was elected to be the first president of the Industrial Design Society of America, called the IDSA. And while he was the president there, he learned about that the National Transportation Division of the federal government was looking for help in developing a signage system. So he used his clout with the IDSA and the AIGA, which is the American Graphics Association, to convince the Department of Transportation to allow him and his team to oversee this design process. So to step back, during the early 1970s, when Nixon was president, Nixon made a big push to create a partnership between the government and the arts for the benefit of the American people. And during this time, under the Federal Graphics Improvement Program, there were some of the now most ubiquitous logos and visual identities developed. Things like the NASA logo and the United States Postal Service identity. But one of their largest accomplishments was the standardization of the federal highway signs. And this is some of the signs, which again, you're all quite familiar with. So this system of 50 symbol signs was designed for use at the crossroads of modern life. This is a quote. In airports and other transportation hubs and at large international events. Produced through a collaboration between the AIGA and the U.S. Department of Transportation. They are an example of how public-minded designers can address a universal communication need. So initially the committee studied and standardized dozens of symbols like elevators, stairs, mail, telephones, and Dreyfuss was one of those people on the committee. And then the actual graphic designers who had to finalize the pictograms were Roger Cook and Don Shanisky. So they were the final designers who created these pictograms. And to ensure widespread adoption of this system, the DOT ended up offering these symbols copyright free. So even today, you can download them and use them free of charge. And because of that, they were, super embraced, and you see them everywhere. All right, so our next guy is a German fellow named Otl Aicher, and he also developed some transportation pictograms, much like Dreyfuss. But in addition to that, he was the designer behind the pictograms for the Munich Olympics in 1972. So again, you think about the Olympics. That's, the perfect testing ground for symbol communication. You've got athletes and spectators from all over the world converging in one location where directions and information has to be very clearly articulated to people. So using symbols at the Olympics was not new in 1972. It was first attempted in 1948 and became a little more, with ISOTYPE, in fact, and then became a little more systematized in 1964 at the Japan Olympics. However, Aicher in the Munich Olympics was really the first designer and design team to devise a universal symbol grid system. So this is the quote. Aicher and his team developed a cohesive set of nearly 180 pictograms for sporting events as well as services through a strict orthogonal and diagonal square grid where all visual elements were arranged at 90 and 45 degrees. The sum of all the work amounted to a very precise and structured identity with just the right amount of warmth. That was a quote. So to develop these, the Aicher's team created cardboard cutouts of the different figures and put joints on the limbs. So then they could pose them to simulate the different sports. Because again, there were no computers. And Aicher would refer to his symbols as what translates from German to his symbol language. I'm not going to pretend to pronounce the German. So these are just some of the different pictograms for the different sports. And you can see how it's very visually consistent, right? Like the person always looks the same. The different sporting elements are all of a consistent line weight and same level of abstraction. The different symbols appeared on 2,600 different signs and printed materials. They definitely helped streamline complicated information like timetables through these very easily identifiable pictograms. He also used bright colors and the typeface Universe 55. So here are a couple examples of the pictograms in communications. Here's a couple more. I think the brand identity for the Olympics was really nice. Like I like all the colors, and you can see how the pictograms are working really nicely to quickly identify what sport we're talking about. All right, so just to conclude, NeurAS ISOTYPE system definitely became a worldwide emulated example of what we now term infographics. Recognizing an image is so much easier than reading textual information, and a successful pictogram is going to be more brief, visible, and legible than written text in an environment. So, thus proving how infographics, pictograms are an efficient way for recognition, comprehension, and memorization of information. So there again is a museum map, and you can see all kinds of those pictograms that were developed by the DOT in the 1970s that have since been taken up internationally. This is a museum map from Europe. So you can see, you can still recognize all those different symbols and understand how to navigate through the space. And even today's emojis, while probably not exactly what Neurath had in mind, is nevertheless a distant cousin of ISOTYPE. So this concludes part 2 of the lecture series, Picture This. Thank you.